So now you can present your presentation, Ms. Richa. Left your network issue. एक रीजन ये हो सकता है कि जूम इनका अपडेट नहीं है रिचा। कभी कभार ना हमारा सॉफ्टवेयर अपडेट नहीं होता है तो भी वो So now you can present your presentation on the topic of the Frankfurt experiment, Ms. Richa.
Good morning to all. I'm Richa from BSc Second. Today I'm here to present my presentation on the topic the Frank-Hertz experiment under the guidance of Dr. Sanjay Kumar Singh, Assistant Professor, Department of Physics, ST College, Panala. Here are the things which will be studied in the further slides. So, in 1914 April, German-born physicists James Frank and Gustav Hertz had showed the quantum nature of atoms. One year after,
sorry to disturb you. So the first slide, just about the topic is done. पूरा प्रॉपर रिलैक्स फॉर्म में प्रेजेंटेशन दो, कोई जल्दी हमें नहीं है ना। इसके जस्ट ऊपर आपने है ना ब्रीफ फेस लिख रखे हैं आपने प्रॉपर, उसको आप पहले एक्सप्लेन करो और उसके बाद आप यहाँ पर हिस्ट्री का ना पॉइंट वाइज आपने बना रखा है आउटलाइन ऑफ द प्रेजेंटेशन। जस्ट ऊपर स्क्रॉल करो, हाँ ये देखो आपने ना प्रीव्यू ऑफ द थिंग्स टू कम, तो इसको पहले आप डिस्कस करो ना कि first we will go to discuss about history, theory, setup, experiment with neon, computing, है ना। आराम से आप प्रेजेंट करो, कोई मतलब उसमें ऐसा कुछ नहीं है, आपको घर पे बैठे हो है ना, लास्ट में आपको टेंशन लेना है कि अच्छा क्वेश्चन आंसर, ऐसा कुछ नहीं है।
ठीक है। Here are the things which firstly we will talk about the history and then theory and then setup of the Frank-Hertz experiment and then experiment with neon, and then we will talk about the conclusions, references and acknowledgement. In 1914, German-born physicist James Frank and Gustav Hertz had showed the quantum nature of atoms. 1 year after, Bohr's theory of the quantized energy states. In 1925, they awarded with the Nobel Prize for the discovery of the laws governing the impact of an electron upon an atom. Here, it is an explanation of the Frank-Hertz experiment. As we can see that this is a diagram of the Frank-Hertz experiment. On the left side, it is a cathode, and in the right side is a node, and in the center, is a metal grid is present. In the original Frank experiment, mercury vapor in an otherwise evacuated tube was bombarded with electrons. To accelerate the electrons, and the potentials were kept at variable higher potentials than in the filament, with the great potential slightly higher than that of plate. In that plate, mercury vapor atoms was present, and when we hot the cathode, the electrons emitted and they collide with the mercury vapors. An emitter measures the plate current. The small retarding potential between grid and plate prevents contribution to the plate current of negligible kinetic energy. Here it is a graph plotted between a current and potential difference. When the plate voltage is so low that the kinetic energy of the electron reaching the plate is less than the energy of the first excited state of a mercury, the loss of kinetic energy by an electron is inelastic. Mercury atom is negligible, about 1 part of 10 raised to the power 5. As the plate voltage is increased, more electrons are drawn to the plate, so the plate current increases. However, when the colliding electron has sufficient kinetic energy to promote a mercury atom to its excited state, the collision is inelastic and the electron loses most of its kinetic energy. As a result, the small retarding potential between the grid and the plate may be sufficient to prevent the electron reaching the plate. The onset of inelastic collision is thus accompanied by a drop of plate current. In this, elastic collision is that collision in which no loss of energy and as a result, the increase of kinetic energy and the more current will be produced. And in elastic collisions, loss of energy and the loss of kinetic energy, so small current will be produced, and which is measured by a milliammeter